Okay, let P equal Chris earns $20. Let Q equal Chris buys gas. Let R equal Chris drives to Rockville. Assume the following premises: if P then Q, if Q then R. So for each premise below, we're going to write the conclusion in words, if any, which follows. What this means is you're going to pick one of the givens. So these two given premises, you're going to connect to A, B, C, D, and E, depending on what they give you. So why don't we start with A? It says P. So if I'm just given a P, that would not link to the first one, but that would link to this, or excuse me, that would not link to the second one, but it would link to the first one. So if P, then Q, and then I'm given P. This is what this is, where this first statement matches. This is called modus ponens. And what that means is, if I were to change the words, if you clean, then you party. You cleaned. You can assume then, therefore, that you partied. Or you can assume Q. Now, in words, that would be Chris buys gas. So this means Chris buys gas. Now, you can kind of nerd out a little bit on this one as well, because if I have a conclusion of Q, I could also connect that to this whole second equation. So just to nerd out a little bit, if I take the second one, Q implies R, and then I put a premise of Q underneath, my conclusion, also by modus ponens, is therefore R. And in this case, R means Chris drives to Rockville. Okay. The second one. So that's all for the first one. Second one. For this one, it says Q, so it's a plain old Q. That would not link with the first one. I thought at first it might be modus tollens, but it's not. Modus tollens, the Q would have to be negated. But it does link with the second one. So here's the second one. Q implies R, and then they give you that Q happens, so you can conclude, therefore, that R happens. And this is also based on modus ponens, and R stands for, the actual answer, is that Chris drives to Rockville. So that is B. Okay, let's go to C. C is not P. So which one has the opposite of P? Hold on. Okay, so if I put a not P here, that's nothing. That's not like a logical reason, any kind of like logical, it doesn't mean anything. If I put a not P in with the bottom, it has absolutely no answer. So this one here, letter C, is NVC. Next one, D. This is the opposite of Q. So the opposite of Q would not link with the bottom one, but it would link with the first one. So let's do this one. Let's put this one over here. Let's rewrite the first statement, if P, then Q, and then write not Q as my second premise. So if you clean, then you party. You didn't party, so I can conclude that you must not have cleaned. This is based on modus tollens, which means the conclusion is negated. Therefore, you can assume that the premise is also negated. Not P stands for Chris does not earn $20. Or Chris does not earn $20. Okay, last one. This one is an R, so that doesn't link to anything. So this is also NVC. So maybe, why don't we summarize the two rules? The two rules in logic are modus ponens, and modus tollens. So if you're given P implies Q, for modus ponens, you're looking for another P. I think we explained it as like positive preliminary. They restate the premise in the same way that it's given. and you can conclude the conclusion. This is modus ponens. Now, modus tollens, I think we said like terrible terminal statement. That means you actually have to negate the Q. So it's the opposite of the conclusion. And since the opposite of the conclusion happened, we can assume the opposite of the premise. And this is modus tollens. These are the only two logic laws that always work. Modus ponens is direct reasoning. Modus tollens is indirect reasoning.